Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond. Welcome to the Web Platform Podcast. This is episode number 120, Async TDD and Other Pyramids of Doom. Today in our panel is Danny Blue.
Hey, everybody.
And myself, Erik Isaksen. It's been a few weeks since we've done an episode, holidays and all, but we're back, and we have an awesome starter on the line here. We have Justin Searls and Jen Tenpas.
Hi, everyone.
So we're going to be talking about testing today. Can you guys tell a little bit about who you are, what you do, and what your experiences have been in general with that?
I'm going to defer to Jan while I think about who I am.
It's a good idea. Good idea.
All right. I'm a front-end developer here at Carfax. I actually have been here for about a year. Prior to that, I was about 5 years in the DoD world, so a lot of kind of hairy, scary Java apps there. And now my focus has been mainly web front-end, focus on React.
Have you figured it out, Justin?
Yeah, well, so my name is Justin. I got that far. I'll just have to improvise the rest. I am a software developer that followed that particular experience curve of enterprise Java to agile Renaissance Java to Ruby and Rails to JavaScript, and I still do Ruby. But one of the things that really changed my career in my life was around 2008, 2009. We started building these much more complicated JavaScript front-end apps. And I saw all these agile developers who were all about test-driven development, code coverage, bringing design and craftsmanship to their code. But they, for some reason, gave JavaScript a hall pass and just didn't treat it with the same level of seriousness. And so I feel like I kind of got ahead of the curve by just really focusing on improving tooling and experience for writing well-factored, well-tested JavaScript code very early on. So it's something this is a saw that I've been coming back to for 6 or 7 years, and people who know me best are really sick of hearing me talk about testing in JavaScript. But it's one of those evergreen topics, especially as we get more and more developers for whom, JavaScript's their first language. And so that's why I'm here today to talk about, how we can make that better for everybody.
That's awesome. Erik, like you said, we haven't done an episode in a while because the holidays and stuff. I actually think our last episode was on testing as well. So hopefully we're also trying to hammer home how important it is to actually test your code and how much better you'll feel when you do it.
Yeah, I think a lot of it is that we've been all doing a lot of test-driven development lately, and we just kind of covered the basics of testing last time. And we kind of glazed over the whole asynchronous code piece of it because most of us are working heavily in JavaScript, which is, you're doing a lot of asynchronous code, and we're moving more towards synchronous in some areas, but a lot of asynchronous in general.
Yeah, one of the things that was a real common theme in the aughts as extreme programming started to become popular is that you teach people almost a dogmatic version of test-driven development, right? Where we'd show katas or simple exercises, and then people would grok that, understand the excitement, the endorphins of the feedback loop of red, green refactor. But then when faced the following Monday with their actual gigantic ball of mud, really complex lived-in application, none of those lessons really applied because now they're dealing with this inordinate complexity. Even setting up to get a test to run was way too difficult. And so when you feel that kind of pain and you're still kind of new at something, you don't know whether to blame the process or the tools that you have or the design of your code. And maybe this is a 201 level conversation that we can have about some of the pain points that JavaScript developers run into when they start to get serious about testing.
Now, a lot of people struggle with testing code that has this asynchronous nature because of different reasons. For me, it's been I was also in the Ruby world and doing very testing. I have an input and my function returns an output. If I'm testing a class, I'm only testing the public accessible methods versus privates. in JavaScript, I've tried to do that, and you can do it to an extent with checking return values, checking that some variable was set. But once you start adding in that asynchronous piece to it, you have the nested callbacks. You used to see it was called the pyramid of doom, right? Where it's just like callback after callback after callback, and you have race conditions. And that was the biggest problem to handle. But now we've introduced these other primitives like promises and libraries on top of these promises, and generators to handle synchronous flow, and also async await now, which is in nightly, I think, for Node. How are you handling that, and what are the differences with that?
Well, how I handle it gets me into trouble with a lot of people who kind of like believe that all of these new JavaScript features represent the capital T, capital F, the future of the web, and that these new primitives, like for instance, do make it a lot easier and a lot less painful to deal with asynchronous I/O in JavaScript, whether you're talking about front end or back end code. The issue that I have is that whether or not you're dealing with just callbacks and that arrowhead pattern or that pyramid of doom, as you put it, you feel that pain right away when you try to interleave a lot of application logic with ifs and elses and loops and stuff in with all of your I/O code. And in the olden days, where you're maybe in a more kind of buttoned up design heavy shop, like whether you're doing Java or Ruby, somebody would look at that and they'd say, oh, you got your concerns all mingled up, right? Like you shouldn't be doing your application logic all tangled up with all of your network I/O, because those are different concerns. And so this is going to be hard to test or hard to understand. Whereas in JavaScript, idiomatic conventional JavaScript tangles those things up all the time. Like every app that I come across is, like if you take Express and just beat up on Express for a minute, it's like one gigantic app.js file with like infinity million anonymous functions that are all kind of nested in with each other. And then when that's hard to test, my answer is usually, well, let's separate out, in pure function form, all of your business logic. And then figure out what's left in terms of, because whenever you see async, what you're really seeing is I/O. You're seeing, either a network request or a file system hit or something like that. And that's a separate concern. And so if you separate it out so that all you're left with is the I/O delegating back to kind of pure functions, you get two easy things to test, right? You get pure functions, and that's exactly what you described, Erik, like inputs and outputs. And those are really easy to test because they're really easy to use. So we should try to maximize the number of those that we can write. Whereas on the network I/O side, it's stuff that we don't own. These are like, either host, they're either language primitives now, or they're, host APIs that are provided to us, or they're third-party utilities. And we don't need to test that stuff works, right? You don't test the framework. And so if we can make it simple enough that it's just, there's no ifs and elses anymore, we can just have a single integration test to make sure that it's all plugged together right. And that story works really, really well, except that you end up with what I might consider well-designed, well-tested code that doesn't look like normal idiomatic JavaScript anymore, because tangling those concerns is what developers expect to see in this particular community.
Yeah, it's been Jan and I have actually been pairing together, like pair programming, on a Node.js command line tool, which I've never done before. I've used Node before, but we're doing a lot of heavy I/O, right? We're doing a lot of mapping across different promises. We're using some generators to do coroutines, and it's so easy to get lost in all of that. So how do you approach your design when you're thinking about maximizing these pure functions and separating out these network layers?
Yeah, I think it's easy to get lost when you have complex requirements about when I/O happens in real life, it's messy because things are going to come back in different orders. Some things are going to fail. You might need to aggregate a bunch of different requests, but still have some sort of SLA where you make a response, even if not everything's gotten back to you. And if you view the complication of like how to deal with those complicated networking questions, then you can just separate that as its own problem. So I said earlier, like there's really just like, if you can separate into two categories, you're in better shape: pure functions that you can test with just normal synchronous unit tests, and integrated integration tests that make sure that all of your kind of like code that actually calls through to IO works. There's this third category of like abstractions on top of whatever async primitives you're using, right? So like kind of think of like the async module or some of the fancier methods in Bluebird. The way that I do it is
we're using Bluebird, so definitely.
Sure. Yeah, so Bluebird provides a lot of really cool abstractions for these cases, but it's not always going to exactly match with what your product owner wants the behavior to be. So I would build my own, kind of like convenience module that does articulate that particular behavior, and then just throw some, dummy example functions at that in the form of a test, and treat it as its own, custom, like networking pattern, and still yet a separate problem from either the the imperative application or the business logic. And that takes a little bit more time because you have to think of like, how would I articulate like what these business requirements are from like a networking problem perspective. But what I find is you end up usually in a better place, and the test that results, you can usually you could open source that. You could just release it as like a normal thing because it's just a really simple, easy fixture that explains exactly the problem that needs to be solved without all the gunk of, your application logic being interleaved in the test.
So that brings me to talk about stuff like sit-on or sign-on, because I've used that before in different projects, and I like the idea of testing that this was called, spies and mocks and fixtures and things like that. So I used that with QUnit at one point, and I'm finding now that with web components even, I'm looking at it as stubbing out XXR requests or even stubbing out an entire server. Is that something that's like an anti-pattern or a best practice in your opinion? And if not, how would you do that?
Yeah, so the in your first conversation last month, you guys talked a little bit about sign-on or sign-on. I actually went to Norway last year. I met some friends of the Christian Johansson who made sign-on, and asked for how to pronounce it because I've been pronouncing it arbitrarily for years, and I still none of them had a good answer, and apparently he didn't even have a good answer because it's Norwegian. So we'll just call it sign-on today, I guess. I find that a lot of developers, when they're still kind of novices at testing, will find a tool like this because it solves the immediate problem of a hard to test situation. 90% of the time when you're a novice at testing, the reason that you have a hard to test situation is because your design of your production code isn't very testable. And so I'm very careful and reticent to recommend that people use test doubles or mock objects or spies. If you're not familiar, if you're listening, a test double is like the superset type of any fake thing that stands in for a real thing in your test. The problem is once you've used those, then you've somehow negated some amount of veracity of your test. Somebody else could look at that test and say, what's real, what's fake, and what's like the governing principle behind what stays real and what stays fake. And so you have to be super conscientious about that. Does that make sense?
Absolutely. I experienced it in Ruby too, where we had factories and we had stubs and different types of mocks. And when I brought that to the front end with jQuery, even, it was like, you're stubbing out everything in jQuery just to get to the end point of that. And that was kind of like a code smell, for lack of a better term, that maybe we should refactor this, or maybe we shouldn't, test some of these things. Maybe we should just rewrite some other stuff and test that.
The rule of thumb that I encourage people to think about is that if I have an integration test, so you mentioned like you had factories, that means you're talking to the database. If I have an integration test, I am the purpose of the test is probably to make sure that the thing works. And as a result, if I'm going to fake anything, it's going to be outside of the sphere of the thing that I'm making sure is working, right? So like that means if I have to fake out maybe let's say the Facebook or the Twitter API, when I'm writing an integration test that has factories and stuff, what I want to do is keep the actual application I have sacrosanct and not throw in mock objects or stub out particular methods or anything, but rather provide a full fake server that can sit alongside it. Sign-on, for instance, ships with a fake server, but there's a ton of other fake server opportunities like out there. Like Supertest kind of does the same thing by stubbing at the lower level. Pretender by Trek is another good example. And so that's if I'm looking at an integration test and it's using something like sign-on or our own testable JS library, something probably went wrong, either in the design of the test or the design of the code. But meanwhile, for unit tests, like if what I'm trying to do is cook up a design that like breaks a problem down and factors it well, that's where I use mock objects or use test doubles, is to help discover like, well, if this thing called this thing and that thing called this thing and then that returned this, then I think I'd have a working solution so that I can then hone in on those like 3 smaller dependencies that I've just built. That's where test doubles, I think, really shine. Because you're talking about really, really isolated, really, really focused tests. And the purpose of the test isn't to make sure that everything works. The purpose of the test is to make sure that your design is sound and that you're breaking up the problem well. But that's like, that's very nuanced. And that's not what most people see when they find a tool that lets them just fake out the universe.
Yeah, with the async code too, like I want to do as much unit testing as possible to have more of those, and fewer integration end-to-end or functional. So I do struggle still with that idea of, for IO, do we do like, what is an end-to-end test? What is an integration test? And what is, like BDD? Why would we choose one or the other? And why are there so many different definitions for these?
Yeah, I mean, it's the same reason why there's a million different JavaScript libraries and frameworks that all do the same thing, is because every team on the planet has to deal with testing. Just like every team on the planet, regardless of what backend technology you use, has to deal with the web, deal with browsers, deal with JavaScript. And you end up with a whole lot of disparate opinions, not because there are, thousands of different perspectives, but just because we live in disparate communities. And so we end up with a lot of churn, a lot of like, common language for the same thing. Like I jokingly started calling my integration tests SAFE tests as an acronym for smoke, acceptance, feature, and end-to-end, because they're all words that people use to mean the same thing.
More acronyms.
Yeah, right, exactly. All of my acronyms are at least sarcastic. But I wouldn't worry too much about that. I think the goal that we typically try to strive for is that the integration test makes sure that everything's glued together correctly, that in a deployed environment, the code seems to work as advertised in the broadest sense, but not to get into the weeds of making sure that each individual part is doing its job. For that, it's a lot, more efficient and more, you get better design feedback and you get more local errors when unit tests are what cover that stuff.
Yeah, I've definitely found with integration tests that if I get a failure there, typically that means that I'm probably missing a unit test somewhere, because I mean, integration tests will find errors with communication inside of your app, but usually it's a component or a piece that's broken and you just miss that test.
Yeah, completely.
Yeah.
I think that the on average, whenever I see an integration test fail, it either indicates that I didn't think about a case in a unit level, and so I should address that case with a unit test that covers it, or the configuration is busted, or some other server dependency is broken, and I think in very, very IO heavy apps like we typically see in Node.js, that raises some interesting questions, like you said, Erik, like even how often do you run these, or do you use them as a blocker for deployment when they are flaky?
Yeah, I mean, running them locally versus CI is very different too, like consideration-wise.
That's even just the case with not even just with end-to-end, but just running unit tests. Because it's a weird thing. So I actually ran into a situation just maybe a couple weeks ago where all unit tests were running fine on everybody's local machine, but completely broke in CI, like just running the unit tests. And I actually can't remember exactly what the issue was, but it kind of brings around this weird thing of how important it is that something doesn't just run on your machine, because at the end of the day, it's not going to run on your machine.
Yeah, and CI, for those that aren't familiar, I think most of our listeners are, but For those who aren't, it's a continuous integration environments. So when you deploy from one environment to another, you'll have a lot of times automated tests that run with that.
So have you ever heard of Circle CI or Travis CI or Jenkins? Those are all examples of CI servers that perform your build for you. Yeah, I think one of my favorite quotes is a fella named Cheesy, Jeff Morgan, who lives up in Toronto. He'd say often, like, he doesn't care if, like, he looks at a build and it broke 300 tests, so long as there was one fix for those 300 things that failed.
That's so true.
If he's got to go and change 300 things to fix the 300 changes, then that's a problem, obviously. But very often, like when you see a lot of failures, it's actually not nearly as scary as it might first seem, because it's probably a configuration thing. It's probably one central thing that everything else depended on.
I think that's something that the Angular community is actually pretty used to. Especially, like, I actually think Angular 2's testing stuff is pretty solid. But if you don't really understand how the modules work and setting up the modules, you can run into that exact thing where you write all your tests out, everything should be going fine, and then the log you get is just a dump of dependency injection errors. And usually it's just, oh, I forgot to import this one thing into my testing module.
Yeah, and to your point, Danny, too, when you were talking about your continuous integration, and doing even the unit tests can have problems. Like, I've had it where, in jQuery, we had a couple of tests when I was doing this large Ruby app where something like an image source in the view would just swap, and calling out that source from a CI server turned out to be a huge problem. And it's something so minor. So it's like, things to think about with IO are very different than the things to think about with unit tests, but absolutely that there could be problems on either side.
Yeah, actually, I think maybe it's worth spending just a few minutes asking, when you see a lot of unit test failures, like, let's say you're working on a feature, you push up a build, and it breaks a whole bunch of unit tests for not obvious reasons. It wasn't just configuration, but rather, like, the change that you needed to make to one module, one part of the system, actually did, break somebody's expectations in a whole bunch of other modules. Like, do you guys run into that situation easily? Do you have any ideas of what the root cause for that might be?
So one of the things that I do first, and I know this is particularly so I don't have a lot of experience with something like with Travis. I've worked with Circle quite a bit, and Jenkins. But in Circle, what we've had happen before is that, so we have we have our core application, and then we have several modules that are kept in different repositories, and we just install them through GitHub, which works very well. The problem is, especially if you're working and you haven't tagged, and you're not tagging stuff so that NPM knows that something is new and it needs to pull it down, Circle will actually sometimes will cache outdated dependencies. And so I've actually had situations like that where it's actually been a push to one of these not third party, but one of our separate modules that are actually used. And then the next time, and everything runs fine, those tests all run fine, and it runs fine in the initial integration test. But then the next time somebody pushes something to the core application, a bunch of stuff will fail because it didn't pull down the correct version of this library that we were using. So that's a situation that we've run into several times, to the point that now, when I look at the logs, if there's not an obvious error, a lot of times I just rerun the build again without a cache.
Even the versions of your languages or your frameworks, like Node, you can have a problem if you're going from 5 to 6.
Yeah.
What you just described, though, of having a bunch of module dependencies and those end up getting cached in your system. If they're third-party module dependencies, what's nice about having, something like a shrink wrap file, or in being a Rubyist, I really like Yarn because the lock file is so carefully designed. That can definitely protect you, because it's going to bark at you exactly about the problem instead of failing mysteriously. But you did raise a really interesting point, which is like, what if you're a team that just writes a lot of internal small modules, and when you describe your entire system, it's actually like you have to define the system as like a manifest of different Git references of dozens of different tiny things. Is that more what you're describing?
Yeah, maybe not dozens, but that is the type of situation where it is, you know, like this stuff it's not published to npm. We're just using it through Git, and we do what I found out is that if you tag stuff and you update like your package.json to say, okay, this is the actual version I want to get. But a lot of times when things are in development, like we'll just push to a branch. So like we'll push to a v2 branch in a certain repository, and that cache stuff can get hidden, or it doesn't so like even though it does run correctly, Circle is the one that I know does this a lot to be faster. If it doesn't see that anything is new, it just moves past it, and a lot of times that stuff will get caught.
Yeah, and there's not I mean, cache invalidation is a hard problem, right? And it's one of the many problems that you are signing up for whenever you break up your monolith into like lots of smaller pieces, because now you have to deal with versioning between those pieces. Yep. But there's a broader issue here that I think is really interesting, because something that we've seen a lot of test doubles clients. So we're talking about test doubles today, and if you're a listener, my company's name is also called Test Double, which is a little bit of brand confusion. But we're a consultancy. We help teams like, you know, just build code and try to improve things as we go. And what we've seen on a lot of our client projects is those kind of system level tests. So you push up this build, and it's the one that's responsible for pulling in all your other dependencies and running like a server. That is probably the worst place to make sure that the app does what you want it to do. Because if you got a lot of those types of tests, you're going to end up with that build failing all the time, and that build being the one that, you know, maybe multiple teams all need to look at. So you have a tragedy of the commons scenario where you know, when that thing fails, either everyone stops everything or nobody stops and looks at it. And that's really not what you want. So instead, I try to like maximize the locality of like making sure that my stuff works first with unit tests, right? Like if I can describe the logic in a pure function and I can write a synchronous test for it that's super duper local, that obviously gets committed into the repo of that module. But second, and this is something that I think a lot of teams could benefit from adopting, I write module tests that fully exercise everything inside of that Git repo that it's possibly responsible for, and then fake out all of the different dependencies and services that it might need that are outside of that module, so that you can just be certain that the behavior inside of that module is working correctly. And then only like the system level stuff that like would suck all of those different modules and endpoints and so forth in would just be making sure that like you can run a thread through all those different dependencies, and that they're actually, you know, working according to their shared contracts.
Sounds like an easy problem to solve.
Yeah, I mean, it's really. I don't mean to make it sound overly complicated. At the end of the day, it's just like write tests that tell you what that repo is supposed to do and ship that inside of that repo, and don't leave it somewhere else.
Yeah. Oh, I totally agree. So our stuff is so some of our stuff is in Angular 2, and so some of the modules are these separate Angular 2 modules. And what helps with that, I'm just trying to think like of a more specific example of what I believe you're talking about. So what we'll actually do in that case is actually build like a demo application, and in that demo application we can kind of write tests for that make sure that the way certain things are supposed to interact work fine. The unit test is, you know, part is fairly straightforward, where I expect to do this and then this pops out. But sometimes you just miss stuff, especially once you start dealing with the templates. Like I had a problem that I should have caught that I didn't with it was some kind of a forms module. It was like an advanced search component or something like that. Everything went fine. Unit tests all passed correctly. But one of the things that I didn't do is that for the end-to-end test part, I didn't actually try submitting the form from the end-to-end test. I was just calling the methods inside of my unit tests, which of course worked. After then pulling the module into the larger application, it didn't work because I forgot to actually handle submitting the actual DOM element form. So that is at least what I think is an example of the type of thing where the sort of testing you're talking about would have caught that before it got inside of another app.
Yeah,
Is that
exactly.
correct?
Yes, I think that's a really good example.
Going back a little bit too to what you said with like Danny, especially you were talking about Angular 2 and how that's a little different with testing. I've been using the promise library Bluebird with Node, and some of the things that we've encountered are like the abstractions like .map and .coroutine. And I'm lucky enough to have somebody here who knows Bluebird very well, because there are some things that I didn't even realize these abstractions take care of, like, for instance, promises working with generators. So that seems to be a problem with the primitives, but there's some magic that happens in the library for Bluebird that fixes those problems, or fixes in quotes, to make it work together better. So how do we know if we're testing the right things with these frameworks? Are we testing the framework itself or the abstraction sometimes? How do we kind of determine if we're doing that and when we're doing that?
So that's the second time the term testing the framework has come up, and I think for the benefit of the listeners, because I don't think in the JavaScript community this has been as popularized of a notion as maybe this was in Java or Ruby. But when people say testing the framework, what they're usually referring to is, imagine that you've written a test against some promises that are using Bluebird methods, but you don't have a lot of confidence that you actually used Bluebird correctly. And so you start writing automated tests to make sure that the Bluebird works the way that you want. And then you commit those, and then they're part of your repo forever. But they don't really describe like what your app is trying to do. They're just verifying that Bluebird works how you want it to work. And because all code that we write and all tests that we write represent a carrying cost, somebody's going to read that test someday and think, wow, we probably had a really good reason for needing this, right? Like maybe we couldn't trust Bluebird, or maybe they'll get confused and think that's actually part of the application. And so in general, we when we're trying to design a coherent test suite, we do our best to not just test the framework or test the third-party dependency is doing its job. We just trust that the framework itself is well tested, so that our focus in our tests can be just explaining like what does our application need to do. And it's a hard habit to learn when you're coming from a position of either not being able to write a lot of tests successfully against your application, so you're just trying to carve up something small and chewable, or if you're operating from a place of very, very low trust that what you're depending on is actually working, which those are two separate problems, probably not best served by testing the framework.
Yeah, that's exactly what I'm referring to, and a really good definition. So thank you.
But you raised a really good point in the notes prior to the call, which is like, how do we deal with, and what does it really say that all of the different front-end and back-end frameworks kind of prescribe their own test helpers or test automation tools or testing buckets or even just testing ideology. Like if you're on an Ember project, for example, it's going to have out of the box, like here's component tests, here's a model test. And we're using, I think, QUnit by default and test them. Whereas like on an Angular 2 project, you're probably using, I don't know if Protractor is still kind of part of the default stack for integration tests. Yep. But that plus whatever Testacular is called, Karma, and Karma configs for more unit tests. And in addition to like more testing opinions and testing helpers. And the only thing that I'd say there is that if you zoom out and think about what these frameworks do, typically they're abstractions on top of I/O. So again, it all comes back to I/O again, right? Like Ember and Angular, all they're doing is providing really, really rich application abstractions on top of event handling and XHR requests. And so when you think about the kinds of problems that frameworks help you solve, it's usually about I/O. And so when you look at the type of test helpers that they provide you to like, here's how to test that your Ember component works, what they're really trying to make sure is like that you used Ember correctly. And so ironically, even though we're not supposed to be testing the framework is often very much geared toward providing us test helpers that help us test that we're using, that the combination of the framework and our application code is working as expected. And that's not the worst thing in the world. I mean, it's valuable to make sure that our application works. But when the framework hands you those types of tests, you have to know that those are always going to be more integrated than is truly necessary. Like you can always just drop back to a plain old JavaScript function and a plain old, a test that's not at all aware of or encumbered by any framework gunk, and just make sure that the function works. And the more of your application logic that you can keep in that, kind of functional core, the less you're going to have to worry about either checking certain framework boxes or worrying about promises or worrying about callbacks. But there's no tutorial on the web that's going to tell you to do that, because everyone wants you to do everything that you can to be as glued to like whatever framework you've adopted.
Yeah, that's why we found, like, especially working on the project that me and Erik were pairing on, one of the best things you can do is create your tests first and stub out all of your tests ahead of time. And don't even worry about how to actually test them. Just say, here's the name of my test and what it's testing. And then you can add in these other frameworks and these other tools that you need to get the test actually done after the fact. So
I think for like people at like an intermediate level, like before you've really ironed out, like once you have a workflow that's like super reliable for integration testing and unit testing, once you're at that point, you might not need what you just described, Jan. But like when you're in the habit or finding yourself at risk of testing implementation details, like you just described, like make sure that I called this Bluebird method, or make sure that I am enabling this particular Angular feature inside of a test of some other thing that you're trying to accomplish. What you just described with like, let's just talk about, and this is, Erik, you mentioned BDD earlier, or behavior-driven development. When Dan North like invented BDD, all it was using JUnit for Java tests, but being very careful to phrase your tests as it should do X, it should do Y. And that's why we see Jasmine and Mocha with all the describe and it stuff, was to try to frame our heads around thinking about the outcome we want out of our code, instead of just thinking about the implementation details that we want to make sure that our test verifies we followed.
Yep.
It's a good observation. The testing in general for these things, how would you go about doing TDD outside of Node? Because obviously Java's been doing it for a long time, or even BDD for that matter. But a lot of us on the front end, we use Node for tasks and things that are not necessarily server side. But if we're working with Node as an application or an API, even it's easy to kind of get lost in the weeds of how Node works. But there was a tweet somebody had sent at man_yells who asked, insight on doing TDD without Node. So how would we do that?
Yeah, I was disappointed by the lack of yelling in that tweet. I was hoping for something a little bit more outrageous when I saw his Twitter handle. I find it humorous almost at this point, and maybe this is just me feeling old now, that Node has been around long enough that we're asking, how do we test our non-Node JavaScript? Because for years it was the other way around. Like we'd been writing Jasmine tests or screw unit tests or what have you in the front end for years and years. And figuring out how to like get a decent CLI to test our Node.js code was actually a hard problem in 2010, 2011. So it's a good thing that we have this problem now, but I suspect that when people ask it, one of the fundamental problems is Node is a single runtime that you're looking at. It might have a lot of different versions, but at the end of the day, if you're writing tests against Node.js, it's always on V8, and it's usually going to behave pretty similarly. It's going to have a lot of the same host functions available. When you're testing browser code, it's just more complex because you're probably trying to support multiple browsers, and you need to do some kind of build step so that you're testing against the code in a browser. For me personally, like it's not a new tool or anything, but my favorite tool for years has been Testem. That's spelled Testem, like go Testem.
Yeah.
And that's,
we had a show on that with Oren.
Awesome. Yeah. Toby Ho was the original author. I'm not sure if he's still maintaining it, but what's great about it is that it provides a nice, attractive CLI. It can handle launching different browsers for you. It was written to be very adaptable, so almost no matter what testing library you're using. And if you go and check out Testem's repo, there's an adapters folder, and you'll see all of the popular stuff like QUnit and Jasmine and Mocha, but a whole bunch of others as well. in the development story, you can launch one or many browsers that you want, whatever that is, including headless ones like Phantom.js. But then in the CI story, you can have it just restrict to just the headless one so that you can run it against CI. Now, what gets confused and what gets muddied a little bit is like Testum is a Node.js library. It was written in Node.js, but that's an implementation detail. Like as a user, all you have to think about is Testum is a CLI that helps me test browser code. And once you have your mind wrapped around that, hopefully it's not quite so hard.
Yeah, I know we actually had a lot of issues. So I used to use Selenium in my old position, and we had a lot of issues with dealing with like Ajax and like things that update real time with headless browsers. So do you have any solutions in that area as far as when you're doing those types of tests?
Specifically when we're trying to test with Selenium these days?
Yeah, so like for instance, if I want to target, say like I have a table of basic items and I want to test, I'm shooting for ID number 32. Well, that ID certainly might change based on stuff that's going on the server side and the back end. Do you have a lot of issues actually testing the UI with those types of like headless test tools?
Man, we could probably go an hour just on advice about full stack browser testing. So if you're not familiar with Selenium and you're listening, Selenium started as a simple remote control API in Java to manipulate and observe browsers over like a wire protocol. And it matured and got to the point where all the major browsers were supported. It has a fancy WebDriver API that is basically, at this point, the only real show in town as far as open source browser automation goes. Almost every tool that you use, like whether that's like Nightwatch or Zombie or all these other things, are built somehow on top of Selenium's APIs. I think that's true. Does anyone know of like an alternative to Selenium for browser automation that's yeah, so some headless ones like like JS DOM based solutions maybe, but the thing about Selenium that's so challenging is it's extrinsic. You're controlling the browser as somebody who doesn't know the implementation details of what's on the page. All it sees is DOM stuff and text that like the user could see, and that is a constraint, but it can be a liberating constraint if the way that you look at your Selenium tests is this is an opportunity for me to test that the page works as if I was a user. And obviously, like we talked about earlier, for the application logic, for all the internal details, like have more local tests that sit closer to that code. But for the full stack integration tests, like Jen, you're saying, like it would be nice to have the Selenium test that knew about item 37, but that item ID might change. Well, a user wouldn't know that that item's ID is 37. The user would know that that item is called potato salad. So I would typically encourage people to write Selenium tests that wherever possible, ignore the CSS. That's an implementation detail. Ignore the IDs. That's an implementation detail of the server or the API. Just like hone in on the English language. And if something's totally graphical, then that's a great excuse to set up, ARIA attributes or something so that you can select on accessible text instead. And improve the accessibility of your system. And if you just focus on like what a user is actually able to see when you get a failure, typically it would be a failure state for the user as well. Instead of just some arbitrary course of business, hey, I changed a CSS class and now all of my browser tests are broken.
Yeah, the biggest problems I've had with Selenium, and we used it with Capybara at the Ruby place I was at. And we use Mechanize, which is, I don't think it's used anymore really as our headless piece. But the biggest problems I found with that was going from environment to environment with the tests. Because you're hitting the actual DOM, the data can vary. And so if you're testing, like, for instance, if there's some dynamic piece of the DOM that you want to verify, this header has this text, then that could be problematic across different environments. But it is a solvable problem. It's just a problem that I've encountered.
Yeah, and I think that like you raised the point of like Capybara and Ruby. What Capybara is basically it's an abstraction on top of Selenium to provide like a slightly better quality of life versus using the Selenium API, which is very bare bones. One of the frustrations I've had with JavaScript is that there are very few alternatives to Capybara that are not half-baked. Most of them are, weekend projects or have only been invested in for a couple months. Whereas Capybara has now years and years of opportunity to become more rugged, to handle those kinds of cases, so that you can maybe provide a regular expression instead of looking for a particular string. And a lot of those is kind of flaky failures that always happen when you're dealing with browsers in Selenium. Capybara has been able to successfully paper over, whereas a lot of the ones that we see in Node.js just aren't there yet.
All right, we're running close to time. I do want to thank all the people who sent out questions from that tweet that you did, Justin. Thank you. And that would be at 333_Jen. We didn't get to talk about mobile, which was that question. So we can talk about that in a minute before we go. But also, as I said, Manuel's and at Fruits, FROOTS 101. Thank you for that question with modules. I think we covered that. If we didn't, chime in, guys. But mobile is a big concern for testing as well with asynchronous code. Do we want to talk about that, or is there something else? So we're running a little short on time.
Yeah, I mean, I don't think we'd be able to do the topic of mobile testing justice today, other than to say that I think that there's a lot of similar problems where you have a lot of front end and UI heavy people kind of coming into more becoming more rigorous about how they engineer their code that's behind that UI. But UI testing has always been really hard, and so culturally, it's maybe a step or two behind, what are more traditionally backend technologies. It's also such a diffuse place where when somebody says mobile, I don't know if they're talking about, Swift and Xcode and how XCTest has changed over the years, or Android Java JUnit, or if they're talking about cross compiler, building, for example, React Native kind of components.
Yeah, it is a broad topic, and I think to do it justice, we'd probably have to do an entire show on just testing mobile.
And your poor listeners who aren't as interested in testing can just suffer from a whole month of nothing but testing podcasts.
Well, we'll be covering a lot of web components coming up because some of us like Leon Rebel, Justin Ribeiro, and we're running a web components conference coming up in February. It's going to be online. We will have tickets available soon. We're debating on the price, but it will be very, 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 very little comparatively to other conferences. And we do have a speaker from here on the show.
I should probably get my talk ready for that then, shouldn't I?
Yeah. So Danny will be talking about web components on there.
Yeah. And RX. Exciting stuff.
Yes. So we're kind of excited. We're going to have a few episodes about web components coming up and static applications. So we'll skip some testing for a little while, and then we'll come back and cover mobile as well. But I do want to thank you, Justin, for coming on. Appreciate it. Testdouble.com. I've been trying to get you in here, or someone from your team, to come teach us your magic. But we'll see how that goes in the future. I do recommend, though, that if anyone wants to get set up, to get your team up and running, definitely contact Justin and his team.
Yeah, if anything, our goal is to teach people that this stuff isn't magic, right? We're just here to demystify a lot of things that have become blind spots for a lot of teams. Yeah,
and it just to help us understand and wrap our heads around certain aspects of testing. And so if people want to learn more about you, obviously they can go to TestDouble, but where else are you on the interwebs?
Well, I think that the nexus for all matters of my life, including business as well as my brokenness as a human, is probably my Twitter account, which is just my last name, Searls. My wife's a teacher, and so on the first day of school every year, she teaches her kids that to spell our name, it is like the word pearls, like from the sea, except with an S instead of a P, which is a useful mnemonic when we're on an audio-only format like this. So find me on Twitter. Honestly, I got open DMs. If you thought this episode was interesting, send me a DM and we'll chat about it. My job is really just to get to know as many people, trying their best to build high quality applications as I can.
Awesome. Thank you. And Jan, I don't think you're on any social media really, but if people want to contact you.
Yeah, you guys could shoot me a message on GitHub at JTP4. And yeah, you can reach me there.
Nice. This has been episode number 120, Async TDD and Other Pyramids of Doom. Thank you, everybody. We'll see you next week.
Right, thanks.
You want to learn more about what's coming on next on the Web Platform Podcast? Follow us on Twitter at the Web Platform, or on Google Plus and YouTube at Plus the Web Platform. We also need your help in creating transcripts of the episodes and helping to create open source projects under our GitHub organization. Contact Erik Isaksen at eIsaksen
or Danny Blue at D_Blue. That's DEE_BLOO.
Thank you for listening, everybody, and we'll catch you all next week.